Okay, good morning and welcome all for this online series of Karnataka State Board 2027 board exam preparations. So this is Gurudat Nadigar. I am based out of Davangere in Karnataka, and I will be your tutor for this whole year, teaching you Kannada, English, Maths, Science and Social. And this is the first problem that I am doing from real numbers. Okay, the question is a very important question where it is given that they have asked us to find, prove that root 5 is an irrational number. So, this is a real number problem and a very important problem. The problem statement is prove that root 5 is an irrational number. And here goes the solution. Just follow me on the board. Okay, well, so let us assume to the contrary that root 5 is a rational number. Okay, so if we assume to the contrary that root 5 is a irrational number, and we know the definition of rational number. So rational number is a number which can be expressed in the form p by q, where p and q are integers and q is not equal to 0, and p and q are co-prime numbers. So we can write root 5 as p by q, where p and q belongs to integers and q not equal to 0, and the LCM of p and q will be 1, where it is defined that p and q are co-prime numbers. So if you cross multiply, you can write it as root 5 into q equals p. Now to remove the root, you just do the squaring on both sides. So do squaring on both sides. So if you do that, root 5 cube whole square equals p square. So root 5 whole square, see, I'll just do the rough calculation. Root 5 whole square can be written as 5 to the power of root is 1 by 2 whole square. So this two gets cancelled and what remains is only 5. So root 5 whole square is 5 q square equals p square. Clear? So here we can see that we can okay, if I write this as p square by 5 equals q square, I will just rearrange the terms and write 5q square as p square by 5 equals q square. Then what you can observe is 5 is dividing p square. P square is divisible by 5 and the quotient is q square. So we can write p square is divisible by 5. P square is divisible by 5, and if p square is divisible by 5, p is also divisible by 5. You may ask me the explanation for this. How does it work? Okay, it's like p square divided by 5 is q square. P square is divisible by 5. The quotient is q square. Okay. So for example, if I take some square number, like say 36, okay, and it is divided by 6. So its square root. The square root of 36 is 6. So if a square number is divisible by a number, its root is also divisible by the same number. So if 36 is divisible by 6, its root, that is root 36 is 6. 6 is also divisible by 6. So likewise, we can say if p square is divisible by 5, then p is also divisible by 5. So we can write what can we write is that p by 5 is some other integer which is r. I'll just consider r as some other integer where r is some integer. R is some integer. So cross multiply, I can write P is equal to 5R. P is equal to 5R. Again, if I do squaring on both sides, I can write as P square is equal to 25 R square. And in place of P square, if I consider this as equation 1, in place of P square, I can write 5Q square. So 5Q square equals 25 R square. 5 ones are 5 5s are. So Q square equals 5 R square. And if you observe this, I can write this as Q square by 5 is some R square. Again, 5 is dividing. So I will continue the problem here. Okay. So here what you can observe is that Q square is divisible by 5. If Q square is divisible by 5, I'll just erase this part, and I'll continue the problem here. Okay. If Q square by 5 is some R square, so we can write Q square is divisible by 5. If Q square is divisible by 5, Q is also divisible by 5. Now what we got is that P is divisible by 5 and Q is also divisible by 5. You can say both P and Q are divisible by 5. If both P and Q are divisible by 5, then 5 is a common factor of P and Q. 5 is a common factor of P and Q. So if 5 is a common factor of P and Q, then we cannot say P and Q as prime. So just erase this. We can play back this video and look at this steps. Okay. But for the moment, because the problem is little lengthy, I will erase this and continue the problem. So we arrived at this point where 5 is a common factor of P and Q. So if 5 is a common factor of P and Q, we cannot say that P and Q are co-prime. So now P and Q are no more co-prime. Okay. So P and Q are no more co-prime. So continuing the problem, we can say that 5 is a common factor for both P and Q. 5 is a common factor for both P and Q. So, but this contradicts the fact that P and Q are co-prime. They are no more co-prime. Okay. This contradiction has arisen. Has arisen because of our incorrect assumption. Because of our incorrect assumption that root 5 is rational. So root 5, whatever we assumed in the initial stages, that root 5 is rational, that assumption is wrong. So this contradiction. So the meaning of contradiction is opposite meaning. We assumed that root 5 is rational, but root 5 is no more rational. It is irrational. So therefore root 5 is irrational. So root 5 is irrational. So this is the end of the problem. See, this is a very important problem, been asked several times in the board exams repeatedly. Almost a confirmed kind of question. The numbers may change, but the steps are same, the method is same. Please practice this question several times, okay, and try to solve this without looking at the board. So I will keep continuing my series of problem solving. Okay, see you. Bye.